Today's presentation is on the nuts and bolts of simulation. Essentially, we want to learn a little bit about simulation and really compare some of our options here. So we're going to talk first about why is simulation even important? And then we'll go into the different types of simulation that we have available through MCAM. I also want to take just a moment to chat about lathe because we're not really going to be spending any time on that today, but that is thoroughly covered in other places. Then we're going to look at some reasons why these might be different from each other, why they can be similar to each other, and then we'll take a direct comparison between these options. And then we'll wrap that up with Q&A. So let's go ahead and start with why simulation is so important. It's really important to use simulation when we are doing work that can be a little bit more complex or might involve machines that have more than a few axes. And this is especially important because these machines with these rotaries, you can have multiple solutions to problems. You have extra collision potential there. And so it's really good to use simulation to help protect your machine. We can always move electrons inside of our computer much easier than we can move metal on machines. So finding problems with simulation is generally going to save us a lot of time whenever we have to change something with a program, as opposed to having to change it out on the machine. So it helps us confirm that we have the correct approach in general. This also allows us to check our toolpath against our model, and we can use comparison tools to make sure that we're actually cutting it correctly. Whether or not we have gouges, or if we're leaving material on a face, are we leaving the right amount of material based on our approach, and maybe combinations of toolpaths that might be coming into the same area. This is also what I see as a very, very cheap form of insurance for these machines. I mean, you're looking at easily a couple $100,000 for any of this type of machinery, really, and it can go way up from there. And these simulators, they're just like they're 1% or less than the cost of some of these things, because it's really not that expensive to bring this simulation in to do this check. And so I think that that's a great way to insure your machine against potential problems. Now, this doesn't necessarily fix problems that are operator errors. If people are setting tools incorrectly or something, there's nothing you can do about that with simulation, but you can at least make sure that your programming is correct before it gets to the machine. This also helps prevent tool breakage from things that we might not see in the Mastercam backplot per se. Something where a tool might wrap it across and run into something else. You could break tools and scrap parts. So this helps prevent that by catching it here. This is also just good for peace of mind. Machining can be a somewhat stressful career, and anything that we can do to help ourselves do a good job and not be so stressed about what we're doing, I think that's a win. So I'll take it. After working on this and working in Mastercam a bunch over the years and really understanding what it's like to program with and without simulation, I want simulation on everything, even if it's more simple stuff, 3-axis kind of stuff. I still like it. It's just a thing that makes me feel better about how I'm doing my job every day. So there are a few different kinds of simulation available. Obviously, there's backplot. That's sort of a type of simulation. It's extremely lightweight, but it kind of counts. We're not going to be covering that today because I don't think that anyone here is really that interested in it. Everyone kind of knows how it works. It's very straightforward. It also is not actually a very good checking tool for really much of anything besides seeing the general motion of the toolpath. But then we move up to Mastercam Verify, and I think that this is the first viable type of simulation that you can use for your program. We are going to go over this, not spend a ton of time on it because most Mastercam users are pretty familiar, but there's a couple little tips and tricks I'd like to give you inside of Verify, and we can use this to compare against our other options as well. We also have Cimco Verify, which is a different Verify product that's from Cimco. And you might know Cimco from some of their other products, such as Cimco Edit. They also have, their DNC systems, which help get the programs out to the machines. They have MDC to actually take data from the machining centers, bring it back for analysis and making sure that your running well. So they make a few products for Mastercam, and we're covering 2 of those today. Then we'll talk about the Mastercam simulation, which is built in with Mastercam for free. We'll talk about Postability bundles, which if you've been our customer before, you are probably familiar with that. It's a post and simulator combination that we sell that does a really, really good job of doing simulation and posting and keeping all that information tightly interwoven. Then we have Cimco simulation. I forgot to change this. It says verify, just simulation. So they've got their own version of simulation that is a little bit different because of the way that it runs. So that'll be interesting to see. There are also some other third parties available, and that would include things like your Vericuts. And we're not going to be covering those today because they vary so much and there's a lot more setup involved. And it's also not something that we can directly help you with. So I'm not saying that those options are incorrect to use or, you shouldn't use them. If that's the right choice for you, then great. It's just not something that we're going to cover today. So before we go any farther, I do want to address lathe because lathe is not going to be covered in today's presentation. Mastercam lathe is pretty limited in what it can do for simulation. And if you have a traditional MP post for your lathe, you will be limited to only using Mastercam Verify. This works, and especially if you're just doing turning only with no milling, that could actually be just fine. I don't really see a problem with that. But if you're getting any kind of milling in there, there are some potential issues with Verify that can be addressed by moving to what's called a dot machine environment. The dot machine environment is Mastercam's built-in system to fully simulate a machine. And we can see an image of it here on the right-hand side. This accurately shows the turret, all of the tooling blocks, which we call locators, the tools, the spindles, the chucks, the jaws, stock, everything. It's all there. This is generally the way that we like to see people go when they have a machine that has, say, a y-axis with their turret, or if you have a b-axis machine or a dual stream. And in fact, you being able to program well with dual streams and getting all those tokens to interact correctly, that is the major benefit of these dot machines. And Mastercam actually developed their own system to do this, and that's why it works so well. Just recently, I did an install on one of these with one of our customers, and they were quite concerned about how difficult it would be to program this machine. And after talking with them for a little over an hour and a half maybe, they realized that this was by far the easiest machine that they could program, and they love it. So I really like going that direction if it's available. But it's not available for every machine. There is a knowledge base article on our website that actually compares these two. There's about a 10-minute video you can watch on that. So I'll go ahead and add that into the chat here. So I would recommend that you go check out that link and watch that video a little bit later. I think that it's a really good thing to watch if you're running blades. So between these options that we talked about a minute ago, what could make them different from each other? So there's 2 general ways that you can run a type of simulation. You can either run an NCI simulation or a G-code simulation. NCI meaning that you're pulling information directly from Mastercam, not posted code. It's generally thought that G-code simulation is more accurate than NCI simulation, and in many ways that's true. But it's not strictly true. There are some instances where the NCI simulation is just as good, and we'll talk about that. Some of the comparison tools are a bit different between some of these functions and options, so we'll take a look at that as well. The ability to create files for the shop floor. This is something that I think is criminally underrated, and it's very, very useful for the shop floor for you to be able to create files to send on the shop floor and make sure that they have a good understanding of what's happening. So it's something beyond a setup sheet, and we're going to get into that as well. The level of data density inside of these different options can also vary quite a bit, some of them being extremely data dense and others having hardly any at all. Uh, Now, does that mean that you want more data? Well, depends on your situation, and I think that it's a case by case analysis. There's also a question of the speed and precision of the simulation itself. Some of them are just quicker than others. Others are more precise, maybe, or because of that data density, there's more analysis that you can do and get a more precise result out of it. So we will see a little bit of that as well. In terms of what's similar between these systems, all of the ones that we're going to look at today integrate very well with Mastercam, and they all have the ability to load in your tools, fixtures, holder, and stuff. And how are we doing so far, Jeff?
No questions here.
Okay, great.
Still sounding pretty good.
Excellent. All right. So I want to start with Mastercam Verify. Let's look at a couple of pros and cons here. So, of course, the first thing is it's free because it's just built into Mastercam. It's ready as soon as you install it. It's fairly easy to use. I find the interface to be pretty intuitive, and it's fairly quick for what it's doing. You can bring in a program and verify it somewhat quickly, and this may depend on the level of data density from your NCI, but generally you can get it done a lot quicker than trying to figure out backplot, for instance. The tools that are used inside of Verify to compare and make sure that we're cutting to size are very good, and they're easy to use as well. And there are options for collision detection and stoppage inside of Verify, which is nice. This software also has the ability to create some of those files for the shop floor. We'll take a look at exactly how that works. And we have 3D controller support. Not everyone's a 3D controller user, but if you are, one of these guys here or smaller, it's really nice to have these, and being able to use them in simulation is great. Now, the downside of Verify is that it's only using NCI data. This means that it's limited in what it can actually read, and any motion that's between vectors may not actually show very well. Now, you could see multi-axis motion okay, but it doesn't really show any movement between planes in, say, a 3+2 or 3+1 environment. There's also no real awareness of your machine kinematics in any way. There's no awareness of the work envelope either. So if you're somewhat close to your travel limits, you may have a problem running in Verify and thinking it's fine, only to find out that it's not going to work at all in your actual machine. You also have a limit on your collisions because it will only find the collisions that are not involving the machine components themselves. So let's take a look at an example of how Verify runs. And we're going to be using the exact same file with the same part and everything for all of the examples today. So I have this entire program here, and I can select all of my toolpaths, and then just click this Verify button here. And that's going to bring me into the Verify window. And we can hit play, and it runs the simulation. Now, it's not getting us all of the information, right? I don't know what the machine looks like around this. I don't know where I might have a collision between the spindle housing and the table in a 5-axis machine. There's just a lot of uncertainty here. It's really pretty limited in what we see. So that's the main problem with Verify.
Hey, John, it looks like Demio's, I don't know if you can refresh the share, but it's like locked up.
Sure, let's go ahead and do that. Yeah, this would be an unfortunate presentation to have that be a problem. All right, how's this?
There, that seems to be refreshing properly now.
Great. Okay, let me start this over. So as it runs, it's basically just jumping between vectors in 3+2 and then running. And it's doing a good job of showing us the result here. But again, we're missing some of that machine kinematic information. We don't see any moves in between. So there is a bit of a limit here. But I think that this is a good solution for just kind of checking your work on an intermittent basis. If I'm programming for this machine, I don't necessarily run simulation every time I add a toolpath or every time I make a change. I will probably do most of my checking just with verify because it's quick to launch. It's quick and easy. And on that note, one thing that they added in 2024 is this really awesome feature where let's say that I'm happy with everything up through op 5. So I've created a stock model, right? I only want to check the operations after this. So I will include my stock model in that selection, shift click to my last operation, and then click verify. When you do this, it takes that stock model and uses it as an override for the stock in verify. So that's my starting point, which is really useful. It's really handy. I like that a lot. There are ways to do the same thing with the other options we're going to look at today, but they all take extra steps, right? So that's something to consider. We do have collision checking options here. We also have the ability to set stop conditions. So if I do have a collision, this will stop automatically. And the other thing I really wanted to show you in here, on the far right of the Home tab, there is a button that says Save Presentation. And this allows you to create an executable file, or .exe, that will take everything in Verify and package it into a single file. And this is really a very useful tool for sending out to the shop floor. If you have someone setting up a machine and they want to see what's going to happen in the program, you can send them this file and they can basically run Verify with all of the tools and gadgets that you have as the programmer, but they don't even need Mastercam installed to do so. So that is pretty neat. I do think that we recently heard about one person having a problem with this, and I'm thinking it's probably a problem with creating this in a 64-bit environment and trying to run it in a 32-bit environment. So I think that there may be an issue with that.
This is probably not a big issue to most. This particular individual was using a machine that was over a decade old. Yeah. So the presentations do require a 64-bit operating system. If you've been running Windows 8, 10, or 11, it'll run in those operating systems.
Right. But if your shop computers are Windows 7, you will need to double check if you're running 32 or 64-bit, because I believe it came in both flavors.
Yep.
So that is one little caveat, but I think that most people are going to be able to get past that pretty easily. You could even run this in something as light as a Chromebook, and it would be okay. I mean, it will run. It doesn't take as much computing power as real Mastercam does. So it's a very neat feature, and I like it a lot. We're going to see this button as a bit of a theme today, actually. So that's the basics of Mastercam Verify. Again, it's a great tool for checking as you go, but it does miss some very important information about the way that the machine behaves in general. So the next one to talk about would be Cimco Verify. So this is Cimco's own Verify product that you can purchase and you can add to your Mastercam. This does integrate directly into Mastercam, so you don't have to, do special exports and things like that. It's basically a 2-button click and you're good to go. It is pretty easy to use, in my opinion, and it also runs faster than Mastercam Verify does in general because it is better at utilizing the GPU of your computer. Now, if you don't have a GPU, this will actually cause a major problem. Some people don't have a GPU in their system and they run Mastercam. It's not technically supported, but a lot of people do it anyways, usually to fairly poor results, but working results nonetheless. If you don't have a GPU, Cimco Verify simply isn't going to run because of some of the requirements that it has. This also caused Tim a problem because he's running Parallels and it doesn't have the correct OpenCL rating, I think. So that caused a bit of a problem. Cimco Verify also includes collision detection with stop conditions as well. On the downsides of this, it is just like Mastercam Verify, only reading NCI data. So again, we're not actually seeing things like vector changes between operations because NCI data doesn't contain that information. That's something that's post specific. It would only come from your posted code or from the rules set in your post processor. The Cimco product also cannot create those exe files that we just saw a minute ago. So that is something to keep in mind. I think it's a useful thing, and if you want to use that on a regular basis, Cimco Verify may not be right for you. Also the stock model quick start, where I just selected the stock model and everything down, that is not something that's actually supported inside of Cimco Verify. That's not to say you can't start from a stock model. You can. There is an option to do so, just not with the quick selection like we saw a minute ago. Additionally, it's not free. There is a cost to it. And the Cimco product does not have any 3D controller support, meaning all of your manipulations of space and view inside of Cimco all have to be done with a mouse. So let's take a look at how Cimco Verify works. This comes in as a tab here, and granted, you can modify your tabs. I could create one big Cimco tab with all of my products on it, but I kept them separate. And we'll see that there are two buttons with Cimco Verify. The first one is the setup, and here I can select my workpiece, fixture, and stock. By the way, Cimco, I'm going to give you major props here. Whenever you use the from level option in the Cimco products, the level selector shows you the name of the level and the number. I love this. This is the best thing. Mastercam really needs to add this everywhere because this is a fantastic feature. I know that not everyone is a levels person. I am. I name them a lot, and so having that is super useful. By the way, if you did want to run the stock model idea that we had before, you click this drop down and use the stock model selection down here. And this gives you the option to pick your stock model, which shows both the name and the operation number. We're going to leave this as stock setup. Now let's select all the operations and go ahead and verify. And that brings us here. So similar to Mastercam Verify, we see our fixture, stock, part, and tool. We can click play to run that verification. What's really neat about this is the speed. If I max that out, it's already done. It's running very quickly. And again, that's because it's utilizing the GPU or the graphics unit of the computer more effectively than Mastercam products do. In this particular scenario, it works quite well because my computer has a very high-end graphics card in there. It's the 3080 Ti. It's not even a professional card, which may actually run even faster in a situation like this. But it's able to utilize that more effectively, so I can really get the speed out of it. Another thing that's kind of interesting about the Cimco products is that this slider here actually goes two ways, and you can run the simulation in reverse. So you can actually see it replace material, which is pretty fun and could be useful.
Yeah, this is the ground workings of additive manufacturing simulation, maybe.
Yeah, it could be.
3D printing this, John.
Exactly. So it just gives you a couple of other options, different ways to approach Verify. You'll also notice that the general graphics of this are a bit different. The colors are different, the style's kind of different. And it also has a sort of view that's a little bit different than the way that we are normally used to it in Mastercam. If I were to say, go here, zoom in, there is orthographic view or perspective view. So I could go to perspective and I can get a view more like this. So which one's better? Well, there isn't necessarily a better, but there could be a preference. Me personally, I actually really like the perspective view versus orthographic, but some people prefer the orthographic just because it's more similar to Mastercam. Let's see, we also have comparison tools built right in. So when we open that up, we can set our range. Let's say 3000s, we'll activate it. And we're going to go ahead and turn off our workpiece over here. So we're just looking at stock. And we'll put it down. And then you can see kind of what it looks like. You can take your mouse and just hover over any point and it will tell you where you're at in terms of stock. So if I look in here, I can see, oh, I might have some positive stock here, right? Or here, I have a little bit of a gouge from one of my operations. I need to go find that, right? So I think that that's a really neat function. I do like that. I actually kind of prefer this over having a big table of all the different colors and what they mean and having to decipher. Just take your mouse and roll over it. It's pretty nice. So,
Add in something here. The advantage of also having a reverse feature where it adds stock back in is that other things like verify or the Mastercam machine simulation that we'll see, you can't actually go backwards and add stock to toolpaths. You have to reset the entire simulation and run it from the top back down again. So advantageous, I guess it'd be faster maybe if to be able to rewind and have stock be added back to it. So +1 for Cimco Verify in this case.
yeah, absolutely. I think it's a great little system. I really do like it. My main complaint with Cimco Verify, I actually have two. The first one being you can't create those files for the shop floor, right? That exe file from earlier, there's no way to create it here. And that is really unfortunate. You know, I can save things as an STL, but that's not the same thing as sending to the shop floor this entire simulation for them to run. So there is a limitation there. And then the second thing is the lack of 3D controller support. And you know, this is something that for you guys, if you're not using a 3D controller, you probably don't care about. But as someone who has only used a 3D controller for the last 4.5 years, as soon as I don't have one, I get kind of lost personally. It really throws me to not have that. And I think that people who spend a lot of time programming are probably in the same boat. So I do want Cimco to add that. I'd really like to see that come in a future update. All right. So the next thing to talk about would be the Mastercam simulation. So this is the free version of simulation that is built into Mastercam itself. The benefits of this is that it is somewhat kinematically aware. You can get the general idea of the kinematics in this. This also matches your verify interface. So at least you have some consistency there and you're not learning something new. This also has the ability to create those exe files, which I highly appreciate. And you can customize your own machines for free. You can do it yourself. This is really awesome, and may in fact be totally necessary, as we'll see in a moment. Additionally, we do have 3D controller support. Now, the downside of Mastercam simulation, it is still reading just the NCI data. This means that it's still not going to show us any kind of like vector change between operations using the same tool. We don't get to see that tool move around. We also don't actually have any control for the rotaries in terms of the bias. So some machines have a maybe a trunnion that could swing two ways, and you might want to force it one way to make it so the operator has an easier time seeing what's happening. And we can't really control that with Mastercam simulation. While we might have a post that has a switch that allows us to do so, we can't double check it and verify because since it's a post switch, it's not part of the NCI data and it's not being read into simulation. Additionally, when Mastercam is installed with this, there are a handful of generic models that have general machine kinematic setups, but the actual physical space of these machines and their size is not necessarily going to match your machine. So that could be a big problem in terms of work envelope or collisions. Generally, it's also a little bit limited in its full data and analytics compared to some other options. So let's take a look at the same file, but using Mastercam simulation. We can find that in the Machine tab, and there's a button for Simulate right here. Before we go there, I'm going to click the Simulator Options button, which takes me to the final page of my machine group setup. for simulation. So we're going to be using the VMC TTBC. So that's a vertical milling center table for our rotaries B and C axes. And that gives us this machine here where we kind of have a y-axis trunnion and then we have the platter on C. And I chose this one because the post we're using is for a UMC 500 in this case, which is a similar layout. It is obviously quite different than this, but at least the general axes are pointing in the same directions. So we can run that simulation here. You can also switch back and forth between Mastercam simulation and verify by going between these two buttons in the upper left. So here we see the general layout, and it looks like, basically if you take everything but the tool, stock, and fixture out, well, we're back to verify. And that's because it's basically what we're doing. We're adding in some skins to show the rotations more visually, but ultimately it's still verify. It's just verify with a couple extra pieces on there to make it more visually complete. And that probably was not even possible for you guys to catch. So we'll go ahead and really slow this down. And I'm going to switch this to time mode. This allows us to actually run it in real time, which is somewhat accurate. And we'll see it run. What I'm going to do is stop it right before we get to this, this vector change. Okay. So I'm going to use this button to move line by line backwards. And so here we are. We just finished facing. And if I zoom in pretty close, we can see the next move has us pull up slightly. All right. The next move snaps us all the way down to here. I mean, that is one line of NCI data that moves us from one op to the next with no actual view of how far did our tool retract? What did the rotary reposition look like? Did it spin? Which way did it spin in C? There's no good visual for this. And that is where the NCI data comes into play versus reading the actual G code or at least reading post switches. So it's a little limited, but it still gives us a general idea of how that machine is going to run. Now, the benefit here is that the skin that we see out here, it is obviously a generic, but you could replace this. And you can do it yourself if you have the files to do so. You just need to go get those mesh files from the machine manufacturer or your machine reseller to build that yourself. And we do have an old presentation on how to do this. And what we'll do is we'll make sure that gets uploaded to the mcamnw.com/videos page, and you can watch it there if you're interested in building your own simulation. If we were to replace the skins here with, say, the UMC, we could do some amount of collision checking during operations, as in, between the time of the start and end of the operation. You just wouldn't get a good chance to check in between operations for any of those vector changes. So that's still a bit of a danger, but it comes down to how confident you are in your post and some of the options you might have enabled in your posts. The Mastercam simulator does support TCP. So if you have TCP on your machine, you can turn that on as a simulator option, and it should display correctly. Jeff, do we have any notes, questions?
No questions on it just yet. I was going to post in a DIY link. We don't have a dedicated link for right now, but if people are curious about what that older presentation looks like, there's a work drive link that you can copy and paste in to take a look at that.
Excellent. Thanks, Jeff.
Post it in the chat.
Because this interface is basically verify, it means that we do have the option to save a presentation file. So this gives your users on the floor even more information to actually check that program out there on the shop floor. So overall, it's good. It's a nice step up, but it's still lacking some things, and it it could use a bit of improvement. You can put some elbow grease into it yourself to make it a little bit nicer. But ultimately, I don't think it's necessarily a great insurance program for your machine. It's something that I think can be useful in some circumstances, but depending on your circumstance, this might be just right for you. So if you have a question about what you think is best, definitely give us a call and we can help you figure out the best direction to go. All right. So next would be the postability bundles. So we've talked about postability bundles many times here at MCAM Northwest. These are machine simulations and posts that come packaged together that are meant to work as a team. They're meant to work together. What's really neat about these bundles is that the simulations themselves, it actually reads data from the post and your switches in order to create a more accurate simulation. This also can show all of your rotary movement accurately, even those vector changes. Because it's reading the data from the post processor and the switches, it actually knows how that machine behaves and can show interpolation motion between vectors. So that is really cool. Additionally, all of these bundles can be customized exactly the way that you want it. So if your machine has a particular set of funky parameter setup that makes it so it behaves differently than any other machine of the same make and model, that's okay. We can make sure that the post and simulation works correctly for that machine by working with Postability, because they're very good at this. It's what they do. There are also much more extensive data analysis tools built into these bundles because they are using a different interface for the simulation. They're actually using the module works interface. So that means that we get a lot more panels, a lot more options and data. And depending on your situation, that might be very beneficial for you. This also has the ability to create those exe files for the shop floor, including all of that data. So it's a little bit bigger of a file and it takes a little bit more to run. But if you are sending complex programs to the shop floor, that is super useful for the shop floor guys. And of course, because it's module works, it does have 3D controller support. So that is a nice bonus. Some of the downsides of Postability, though, the interface can be a little bit overwhelming when you first start if you're not used to it. There's a lot going on, and it can be difficult to find the thing that you're looking for when you're unfamiliar with how that system works. So there's a bit of a learning curve there. Additionally, you do need to continue to pay maintenance in order to keep up to date with new versions of Mastercam. So let's say that you buy this in 2024, you're on maintenance for Mastercam, but you don't have maintenance for Postability. When 2025 comes out and you update, your simulator will not work for 2025 unless you stay on maintenance. So that is a bit of a downside. The other side of that argument, though, is that when you stay up on maintenance, it means that you can continue to make changes to your post and simulator as needed. So for instance, if you've changed parameters in your machine because you changed the way that you run your process, you might need to update those things. So staying on maintenance makes it easy to do that. Or in the case of some machines, controllers can actually get updates and get totally new features later on. And if you're not on maintenance, you won't be able to add any of those to your post or simulator. So staying on maintenance is not a bad thing. It's just something to keep in mind that there is some cost there. Additionally, you will need a bit of a stronger computer to run Postability bundles, particularly in the CPU department, because of the heavy data load and the way that it processes that information. You will also need to purchase a different simulator for each machine that you want to run. Now, there are discounts available when you purchase multiples or when you have spin-offs. So if you have two machines that are pretty similar, we can usually get discount pricing for what we would call a spin-off post and simulator. So let's take a look at an example of one of these bundles. So again, I'm going to be taking this and just running it into simulation. You might notice that I'm running the Postability post already. If I go to my files, we'll see that here, this is marked as a Postability post. So I've been able to use the same post with all of these simulation methods, and that works fine. They do make great posts anyway, so I generally use them. But you will need to use the specific Postability post to run the simulation correctly. So the Postability simulation runs from this group on the machine tab here, rather than the simulator group. We click on this button here to open the options. And this is where we set the machine that we want to run, our workpiece, fixture, stock, things like that. Whenever we run one of these, we must make sure to check this checkbox for Use External Post. And the reason that's so important is it allows the simulation to actually read the post processor and the switches and figure out certain things about how your simulation is supposed to play out. So things like, if I want to bias the trunnion and I have that set as a switch in my toolpath, I actually see that in simulation. So that's really important. Go ahead and launch this. Okay. So here is the environment. There is actually a machine housing available as well. I just have this turned off because it's a little hard to see with that turned on. And we can see here, this is definitely much more detailed, and it's an actual model of the machine itself. We get a good idea of where everything really sits in this machine. So I love that. There are several panels on the side here that we can kind of scroll through to see our different options. And this gives us a lot of data to look at and a lot of different ways that we can manipulate the simulation to give us what we're looking for. So that is, on one hand, kind of a pro because we get a lot of options. And on the other hand, it could be a little bit much when you're first getting started to really figure out how each of these work. And I've been doing these for a few years now, and I still don't know how every one of these things works because I don't use it on a daily basis. But I'm sure that if you used it very frequently, you would be able to pick out all of these settings and what works well for you. We can run this in NC mode, which is kind of fastest, time for real time, or length, which kind of evens out all the feed rates visually so we can just kind of keep track of what's happening. I really like the length mode myself. We can change visibility for several different things, such as whether or not we want our workpiece showing, our tools, fixtures, toolpath lines on screen, so we can actually see kind of a sort of like a back plot in the background. And what's really important, let's go ahead and just restart this. And I am going to play this a little bit more slowly so that we can see the actual change between operations. Finish up the facing there. The tool's beginning to retract, so I'll slow this down a bit. And as the tool gets up to the top of its travel in this move, we'll see the rotary actually start moving as well.
What's going on in the post right now is there is a G91 G28Z0 for that retract the tool all the way up. And it's invoking, of course, the B and C reposition or rotary moves. Then we'll have that reposition move with the tool, and then it'll wrap it back down to its approach.
Right. So what was really important there is the difference between what we just saw and the Mastercam simulation, right? Because in the Mastercam simulation, we don't see any of this rotary stuff happening in between operations because the NCI data doesn't have that. It doesn't know. It only knows what is in the NCI data, which is within the toolpath, not between the toolpaths. We can speed this up and let it run. The other thing to note here is that as this runs, you can kind of see the trunnion tilting, and it's really favoring that one side, and that's because that's how these machines run. That's how a UMC is. You might notice if we go back to the Mastercam simulation using that generic machine, it would actually swing both ways in B because it doesn't understand this machine's specific kinematics, whereas this one does. Additionally, we can create those exe files. We do it from a different spot because this is ModuleWorks. So we go to File, Save/Export, Create Presentation, and then you create it here. Again, I believe that this is the same thing. It requires the 64-bit operating system in order to run. So do keep that in mind.
Big red warning sign there when you go back to the create it.
Yeah.
There it says
running 64-bit, which when I saw that email come in for the ticket, I immediately went to look at this first, and I thought, that's probably what it is, so something to consider. But we do have basically all the same tools that you know and love from other features and other options. It's just maybe found in a different spot. So for instance, if we want to check the deviation, we would go to this analysis panel, which there are two analysis panels. One of them is like a little toolpath icon, and the other one is like a model icon. So that's the one you're looking for. And then you can change the values here to check your settings. So for instance, let's set a range of plus or minus 10 thousandths. And then switch this back to manual. Then I can change the spread here. So let's say we're plus or minus 1 for green. Hit this button, and we can see how this came out. So we can see that there's a bit of area where we've got a little too much stock. I'm not surprised. The step over is a little wide here. And then we've got some areas where we're overcut. I'm not surprised, say, on these little chamfers, because that's not modeled into the part. But it is deburred with the toolpath. Some of this, like what I see in here where there's a little bit of a line, I think that some of this might be graphical noise. And it could also be the accuracy settings. So in the sim, we can change the accuracy here. Increasing that accuracy will slow down the simulation and take more horsepower to run, but it does give you a more accurate result.
There's also, and I think you're going to touch on this coming up, but the tessellation tolerance of the initial simulation when you run it is set to a larger value of about 7/1000ths of an inch. And so what that means is how tightly do we want the simulation to adhere to the toolpath motion? And by having a larger tolerance, it allows you to compute faster. And what you'll get will the compare feature, you might see that faceting or those gouges that might not otherwise be there, but that has to do with essentially that tessellation tolerance, allowing simulation to kind of get away from the toolpath motion as accurately as it needs to. And so that could be, of course, tightened up. It's a lot more work on the CPU, but you'll get better accurate comparisons if you're lowering that to like 1/1000ths of deviation.
Right. Yep. So just keep in mind, if you are using this default value of 7/1000ths, for a lot of people, that's a little too big. I don't really know why that's the default. I think that a more reasonable default might be 2/1000ths or maybe 3. Something where if you're working in kind of the standard plus or minus 5 world that is, the general machining, it's going to catch it. I think that having it bigger than that tolerance is a little bit odd. So something to keep in mind. So we have one more option to go over before we wrap up, and that is going to be the Cimco simulation. So what makes Cimco really different is that it actually reads that G-code directly. It's not taking NCI data and modifying it or reading from the post. It is posting code, then taking it, and then running it. So this is true G-code simulation. Just like Verify, it does run forwards and backwards, so that's pretty nice. Additionally, just like the Cimco Verify, having a good GPU means that you're getting a lot of speed out of this. If we were to go back to Mastercam, let's just so we have something to compare. I'm going to start up the Postability bundle again, and I want to put it at max speed and run it front to back and kind of get a time on it. We'll just estimate it. I should have done this before, but I forgot. Okay, so we set this to NC for maximum speed. You set to NC, you set to max speed, and then you click run. 1, 2, 3, 4, about 5 seconds. Okay, which is not bad, but this isn't a terribly complex program. We'll see how that compares in a minute here. The other thing that's really neat about Cimco simulation is you would have the ability to run old NC files without actually having the Mastercam file. There are some caveats to this. You do need to have models available for your part, for your fixture. You're going to need to set your stock correctly, and you're going to need a tool library built into Cimco in order to do that. But it's an option, and if it's something that you run into a lot, that might be worth it to you. You can also switch out machines that would use the same G-code. So in theory, say a UMC 750 and a UMC 500, they really take the same post. It's all about making sure that the collision checking is right. Well, you could post it for one machine and then run the simulation for both machines with the same code, all inside of one session. And that's really cool. In fact, if you are a Haas shop in general, this could save you some money, because you can buy one license that will cover all of the different Haas simulators that are included with the Cimco simulation product, which is super neat. So some of the downsides, if you have machines that are not a Haas, they are still supported. They can support basically anything, but they do have to be built out. We would need things like receipts of skins from the machine dealers themselves, because a lot of these other dealers have much more strict requirements on how simulation is done. So it's not really Cimco's fault. It's how the machine dealers themselves want to work. I do think that the stock analysis tools are maybe not as intuitive in simulation. There's some differences between how it works in Verify and simulation that are not as useful, at least in my opinion. But I still think it's a pretty good system. It does have significantly less data analysis tools compared to the Postability bundle that we just looked at. So if some of those are important to you, you might miss out on it. Also, like Cimco Verify, you cannot create the exe files for the shop floor, which is a bit of a bummer. And no 3D controller support, much to my personal chagrin. So let's take a look at the Cimco simulation before we wrap up here. So there is an integrator tool that you would install that says run Cimco edit. And when we click it, we get a panel like this, kind of similar to Verify. And essentially, we get a lot of the same stuff. We're not going to talk about this much today. I'm just going to go ahead and launch it. So you'll see it executed the post processor. And then here we get this window, and I have my base turned off, but again, that is part of the simulation right there. I like to turn that visibility off so that it's not in my way. And a lot of times I'll turn the toolpath motion itself off so that I can see a little bit more clearly. On the side, we have our G-code. And what's really neat about this is as we run the simulation, you actually see the lines moving down the G-code itself. But it even means that I can click in a spot and then use my arrow keys on my keyboard. And as I move, simulation follows. So I'm just kind of holding my arrow key down and watching it go forwards. Move over, and then it's doing that. So that's really cool. If we really slow this down here, we'll see it come up. once it gets to its full retract height, we'll see it invoke that B and C motion, and it's moving a little too slow to see. But if I turn up the speed, you can see that motion. So even though when we're using the arrow keys and it looks like it snaps, that's just because of the way that we're looking at the code. If we're using the play button, we can actually see that movement. And then it just kind of runs as normal. It has a lot of the same tools for collision checking, comparisons, things like that. It's all available. Back on the note of speed, let's set this back to the beginning. Set that to max and click play. 3, 2, 1, go. 1, 2, 3, 4, 5. Oh, it's about the same actually. But what this does have that the other simulation doesn't do quite as well is this button right here. Sorry, Jeff, what was that?
Well, what I will say is you are broadcasting a video stream right now, and that's going to use more GPU processing power than takes away from the simulation. What I can attest to, though, is that when you're not streaming, this is much faster than the Module Works simulator.
Yeah, the streaming is kind of hurting it. So if we click this button for jump to end, it's already done. The other simulator is not that fast. If I open this one, we'll restart it. There's no jump to end button here. The best I could do is grab this slider and just bring it to the end. And then it's got to sit there and process, and then it shows it, which is not bad. But again, this isn't a very big program, but it's basically immediate with the Cimco. So that's really nice. Additionally, this also has the ability to change the view between projection or perspective. So if you don't like this perspective view, you can change that. Again, personal taste, personal preference, but no 3D controller support. But what's really cool is we've been running this here. Let's see, I'm going to close the back plot, and we can see here that I have options to run this on different machines. So I'll set this to the 500, run simulation, and I can just run it. And it runs as normal. And then if I want to, say, change this to the 750, I just close backplot, change my machine, and then run machine simulation, and then it brings in the other machine. It's as simple as that. So as long as the code is compatible between the two machines, you can do that quite easily with the Cimco simulation.
Also, because it is reading the G code there, you could go in and fat finger a motion, a new move in there, and it will follow that.
Indeed.
So, like if you went in and changed one of those B0 rotations to like a B120, just to oh, you have to put the C.
I did something bad in code and I killed it, which is my fault, not its fault. But yes, you can actually modify those values directly. All right, so all that said, what's the right choice here? And I think that the answer is pretty clear that there is not a good one-size-fits-all answer to this. I think that using a combination of these will help. So what am I going to do from here out? I'm probably going to use the Cimco Verify myself for general checking because it's really fast. I like the way that it looks. I like the comparison tool. I think it's a little bit better. And as a reseller, I just have a key to it, so I don't have to think about paying for it at all. I'm also not creating exe files for people on the shop floor because I don't work in a shop. But in some situations, I might switch back to the Mastercam Verify because I really like that, the ability to quickly bring in the stock model. That's super nice. For full simulations, the Mastercam simulator might have some uses, but I'm generally going to lead towards either the Postability bundle or the Cimco, depending on what machine I might be running or what kind of application I'm using. I think that really the best way to deal with this is to just give us a call. We can go through what you have on your shop floor and figure out the most cost-effective way to get you a nice, safe simulation and keep your machines running well.